Okay, welcome back. Now, what I want to look at today is quadrilaterals and polygons. Okay, quadrilaterals and polygons. Let's just make sure you can see this clearly. Okay, quadrilaterals and polygons. Okay, now quadrilaterals. A quadrilateral is any four-sided figure. There are special types of quadrilaterals. One, square. Okay. As you can see, it is square. All four sides are equal. Okay. Okay, all four sides are equal, and all the angles are equal, which would mean that they are all at 90 degrees. Okay. Opposite sides are parallel. Okay. Okay. The diagonals bisect each other. The diagonals cross at right angles. Okay. And these would be your diagonals when across. Okay. Right. Step back a little bit to make sure we can get this in view, full view. Okay. And here we are. Now let's look at a rectangle. Rectangle. Here we have a rectangle. Okay. Now opposite sides are equal, so that side will be equal to this side. That side would be equal to this side. Okay. All the angles are equal to 90. All equal to 90. Opposite sides are parallel. Okay. That runs parallel to each other. That will run parallel to this. Okay. Now the diagonals bisect each other, but not at right angles. Okay. And you can see the difference here, that this angle here would not be a right angle, whereas here you can see that that angle here in between at this point here would be a right angle. Okay, that there would be a right angle here. Okay, that would be your right angle. That would be a right angle. Okay, that would be a right angle, and that would be a right angle to here. Okay, just showing you the difference in the two. Let's go back to the rectangle. Okay, there we are. Now another quadrilateral is also a parallelogram. Parallelogram. Okay. Okay, and that here you can see is slightly different. Opposite sides are equal. Again. Okay. And here equal. Okay. And opposite sides are parallel. Okay. Again, running with each other. The diagonals bisect one another, but not at 90 degrees. Again, they does not bisect at 90 degrees. And we've shown you why already. Okay. to bear that in mind. Make sure you're familiar with these shapes because they're going to come up a lot in mathematics. Okay? A rhombus. A rhombus. Now here we are, rhombus. All the sides are equal. Okay? And where have we seen this before? It was similar to the square, isn't it? Okay? All the sides are equal. Opposite sides are parallel. Okay? The diagonals bisect each other. The diagonals cross at 90 degrees. And here you can see again what I've shown you earlier, that it will bisect at 90 degrees. Okay? So you almost look at this as a square. Let me just go back a little bit. Okay? And let's look at that square. Almost look at this as a square. Okay? Ignore these. These are just to try and illustrate at a different point in time. Okay? And let's get back to our rhombus. Okay? Now the trapezium. And here we are, trapezium. Okay. Now this is what it would kind of take the shape of. Okay, here. Or it can look like this. Okay. Okay. One pair of sides are parallel. Okay. And it is important to remember that all the interior angles of a quadrilateral add up to 360 degrees. Okay. And what we're showing you here is that one, it looks like this depending on how you turn it. And here we've simply turned it around. Okay. Now read through the following examples. And what I want to do is to keep in mind the following example as to what makes up the angles. And here we have to look at finding x. Okay. Now we know that this should add up to 360. We are told that that's 105. We know that it's 90. We know this is 65 degrees. Okay. So in this process now we begin to This process now we can subtract 90 from 360, 105 from 360, 65 from 360. But let me look at it a different way. I would want to use the information that I've been given, and let me just try and use my information in a different way. I want to use information 90 plus 105 plus 105 plus 65 okay equals equals 260. Okay, now that figure here I need to subtract from 360. Okay, there are 360. Sorry about that. It's my computer trying to tell me that it needs to restart to update, but you can do it later. Okay, so here I'm going to look at 360 minus 260 equals 100 degrees. Okay, and that ties in with this. Okay, right, so we know that is correct, that x equals 100. Okay, so x equals 100. Now the reason why I'm doing this is to make sure that you understand how important it is for you to actually do the physical work. Okay, you cannot just look at it on the screen and think that you know it. You won't. You have to do the physical work yourself. So you will notice that I try to show you this every time by doing the physical work myself. I can't just say, well, follow this, but it's important that you make sure you put in the effort to achieve your solution. Okay, practice, practice, practice makes perfect. Okay, and here we have to look for to find y. So we're finding y here. Okay, that's what we're looking for, y. Now ignore the fact that that's been given already, but you need to apply the process taking into account the angles that is already there. Now we know that that's 12.5, so again this must add up to 360 degrees. And again here we have 360 minus 205, okay? That comes from here, okay? Minus 205. 93, okay? Come around, that comes from here, okay? And 46, which comes from here to here, okay? You add all these up together as I did here, okay? Applying this principle, add them up together, and it will give you 344, okay? Now you need to check this for yourself, make sure it is correct. I will not be checking it for you, okay? Okay. Sorry about that. Okay. And you'll see that that is our answer here, okay? And the answer is correct. Now again, check that the answer is correct. Don't just take my word for it. And here we have number 3. And again here we need to find x, y, z. Now remember that interior angles between parallel lines add up to 180. So interior angles between parallel lines add up to 180. So x is an interior angle, and that will be in parallel with y. But let's deal with one at a stage in time. Here and here, these two angles here have to add up to 180. So we have here x. Let me change color a little bit. We have a x, which is 180, minus 40, so x equals 180. We know that these two will have to add up to 180, whichever way you want to look at it. Now remember, it is a matter of your perception in each case, okay? And it matters. It's 180 minus 40 will leave you what? 140. So we know that x here is equal to 140. Okay. Y, which is here, needs to come up to 180 in respect of z. So y equals 180 minus 140. And again, as I said, it's in regard to your perspective. That would apply to here, as well as this would apply to x, as y would apply to x. We know x is 140, therefore, taking y into account, which would need to be 180, quadrilateral angles will need to be 180, minus 140 equals 40. So y is 40 degrees, okay? Now again, remember the interior angles between parallel lines add up to 180. So you need to look at that that respectively, that respectively, that respectively, between parallel lines. Okay. Now Z, the angles here has to add up to 180. So Z, we know Y is 40, and the angles here and here should be 180. So we know Y equals 180 minus, oh sorry, sorry, all right, I just lost my place there for a moment. Yeah, that's been covered already. It's okay. So we're looking at Z now, okay, and that will be 180 minus 40, because again Y and Z would be, angles would be adding up to 180. So 180 minus 40 equals 140. So we can say that Z is equal to 140 degrees, okay? And that would be correct. Now again, draw these up for yourselves. Make them yourself familiar with it. Get to know it, okay, overall. Alright? And here we have 4. Now, ignore the mess I've made of this here, on here, okay? Because I was doing some, this is my own work myself, okay? And I used this work before I began to do it online. So you can see that these are quite old. Some of these are quite old, okay? So I do apologize for that. But you can see here that we have question 4, and we're looking at, we've been asked to find Y, Z, and X. We have corners A, B, C, and D, okay? And we know that's 90 degrees already. We're told here that is 75 degrees. That's 35, that's 35. But let's see what I'm saying, because I'm doing this now from memory. Okay, so do please excuse me, but I will not be editing any errors that I make. It stays because I can learn from that myself. So let's look at X. This is one angle here that would be, that you need to look at, okay? That's a whole angle, a whole triangle here basically, okay? Then you got that there in here, okay? So that would be your angle here and here. And I'm just doing this roughly, okay? So okay, and that would be there and there. Okay, I'm just apologize for my roughness, but you can see that would be form one triangle, okay? So when we look at this X is here, okay? X is here, okay? Right? And we know the angle triangle should be or add up to 180. So we have 90 plus 35, which gives us 125 degrees. So X bear in mind this angle here should be one, total angles will add up to 180. X equals 180 minus 125. That leaves us how much? 55 degrees. So X is equal to 55 degrees, okay? Okay. Now let me just pan back a bit to make sure I can get this into play. Okay. Okay. Yes, I can. Let's just move back in. Okay. Now to find y, and this is y here. Okay. Remember again, this angle will need to add up to 180. So we have y here, which now remember that base angles in isosceles triangle are equal. Okay. So I'm just going back to see where if I've missed something out in regards to my isosceles triangles. Let's go back a little bit. Okay. Pardon me. Okay. So y equals, we have 75 degrees here. We have no idea what the value of y is, what the value of z is. But base angles in isosceles triangles are equal. So z equals, we know that should be 180. Okay. Now we're saying here that y is equal to 75 degrees and z is equal to, we don't know just yet. But let's see what we come up with. So we've been given 75 degrees here. We've been told that the base angles here of y should be 75 degrees also. So we have 75 and 75. So we know this should add up to 180. So z equals 180 minus 75 minus 75. And z should be equal to, so let's just see. Now remember 75 and 75 equals 150, okay? 75 and 75 equals 150. So that becomes z equals 180 minus 150 equals 30 degrees. Okay, and all I've done, I've looked at this in a different way overall, okay, so that we can see how we can find a different way of arriving at the same solution, okay, and this is an isosceles triangle, okay. Now don't be confused by all the mess. You can draw out your own, okay. I have not made it simple for you to just to copy it off or to look at it, okay, and that is our solution, and that will be correct, okay, right, and that would also be correct, okay, okay. Oh, they've done it down here as well. They've applied my principle here, okay. So here they are, they've applied it here, okay, okay. All right. All right, let me just go back and make sure that I pan back a bit and we can make sure we get this all in. Let me go back to the top, okay, so we can make sure that it's all visible and can be clearly seen. Okay, so I'll work my way down slowly. Okay. Nothing for me to say here, I'm just recapping what I've done, okay? And that will be us there. Now I'm going to stop there for now, okay? And that's where I'm going to stop at. Okay? But it's important that we understand the concepts behind this completely, and I don't want to rush it. So let's do this in stages. I'm going to call this, let me just get my head in, 1 second. Okay. Right, that's it for now, and we'll continue with this next section next time. Okay, thank you. Have a good day. Bye-bye.